In the previous class, we learned what is polynomial and types of polynomials also. And in that one, we learned zero polynomial also. Zero polynomial means if the value of a polynomial is equals to 0, then it is called zero polynomial. P of x is a polynomial, it is equals to 0, then it is a zero polynomial. Now in today's topic, zero of the polynomial. There is difference between zero polynomial and zero of the polynomial. Zero polynomial means the value of the polynomial is equals to 0. But zero of the polynomial means for what value of variable the given polynomial is equals to 0. That value is called zero of the polynomial. For example, let us assume one polynomial as px is equals to x minus 1. For what value of x, this x minus 1 will equals to 0. That value is called 0 of the polynomial by trial and error method. If x is equals to minus 1, then p of minus 1 is equals to x minus 1 means minus 1 minus 1, that is minus 2. It is not equals to 0. So minus 1 is not a 0 of the polynomial. Next, x is equals to 0. In p of 0, p of x means p of the place of x substitute 0. P of 0 is equals to 0 minus 1 is equals to minus 1, also not equals to 0. Next, x is equals to 1. P of 1 is equals to 1 minus 1, which is equals to 0. For what value of x now it became 0 polynomial. That value is called 0 of the polynomial. That means for x is equals to 1, this 1 is called 0 of px is equals to x minus 1 polynomial. So that is difference between 0 polynomial and 0 of the polynomial we have to remember. So on the 0 of the polynomial exercise, 2 problems are given based on the 0 of the polynomial. We will solve one by one. Here in exercise 2.2, the first main is given as asking us to find the value of the polynomial 5x minus 4x square plus 3 at x is equals to 0. What's the value of that polynomial? X is equals to minus 1. What's the value of that polynomial? X is equals to 2. What's the value of that polynomial? We have to find. So let's come into solution. Let us assume given polynomial as p of x, that is equals to p of x is equals to 5x minus 4x square plus 3. Now take the first one. If x is equals to 0, then p of 0 is equals to, in the place of x substitute 0 wherever the x is. So 5x means 5 into x, that is 5 into 0 minus 4x square. So 4 into 0 square plus 3. So 5 into 0 is 0, 4 into 0 is 0 plus 3 is equals to 3. The next, second one. X is equals to minus 1 here. Implies p of minus 1 is equals to, in the place of x, this time we have to substitute minus 1. So p of minus 1 is equals to 5 into minus 1 minus 4 into minus 1 whole square plus 3. So 5 into minus 1 means minus 5 minus 4 minus 1 into minus 1 will get plus 1. Minus 1 whole square means minus 1 into minus 1, that is equals to 1. So 4 into 1 is 4 plus 3, that is equals to minus 5 minus 4 means minus 9 plus 3. Minus 9 plus 3 is equals to minus 6. And the third one. X is equals to 2 this time. Yeah. X is equals to 2 implies P of 2 is equals to 5 into 2 minus 4 into 2 square plus 3. That is equals to 5 2s are 10 minus 4 into 2 square means 2 into 2, that is 4. 4 4s are 16 plus 3. 10 plus 3 13 minus 16 is equals to minus 3. So at various values of x we are getting different values for given polynomial. And the next second main. Second main asking us find p of 0, p of 1, p of 2 for each of the following polynomials. The first one is p of y equals to y square minus y plus 1, and the fourth one is p of x is equals to x minus 1 and x plus 2. Our second and third given for you as homework. And next we have to find the value of the given polynomial when x is 0, when x is 1, when x is 2. The first one, the solution part. If y given, so y is equals to 0, then p of 0 is equals to 0 square minus 0 plus 1, that is nothing but 1. Next, if y is equals to 1, then p of 1 is equals to 1 square minus 1 plus 1. Minus 1 and plus 1 will get cancelled, remains 1. The next, if y is equals to 2, implies p of 2 is equals to 2 square minus 2 plus 1. 2 square means 2 2s are 4 minus 2 plus 1, that is 4 plus 1 5. 5 minus 2 is 3. Next, fourth problem in the second main given as p of x is equals to x minus 1 into x plus 1. So same here also, if x is equals to 0, then p of 0 is equals to 0 minus 1 into 0 plus 1, that is equals to minus 1 into 1 is nothing but minus 1. Next, if x is equals to 1, next time p of 1 value we have to find. That's why x is equals to 1 this time. X is equals to 1, then p of 1 is equals to 1 minus 1 into 1 plus 1. 1 minus 1 is 0 into 2. 0 into anything, the value is 0 only. Next, if x is equals to 2, p of 2 is equals to 2 minus 1 into 2 plus 1 is equals to 1 into 3 is nothing but 3. The next, third main. Third main asking us to verify whether the following are zeros of the polynomial indicated against them. So this time not asking us to find 0 of the polynomial, just we have to say whether the given values are 0 of the polynomial or not. So just substitute in the place of x, simplify. If it is 0, then we can say the given value is 0 of the polynomial. If not, means it is not 0 of the polynomial. The first one is p of x is equals to 3x plus 1 is the polynomial. The x value is given as x is equals to minus 1 by 3. So substitute p of minus 1 by 3 is equals to 3 into minus 1 by 3 plus 1. 3 1s are 3 1s are get cancelled. Minus 1 plus minus 1 is equals to 0. Therefore, x is equals to minus 1 by 3 is 0 of the given polynomial. What it is? P of x is equals to 3x plus 1. The second one, given polynomial p of x is equals to 5x minus pi. When x is equals to pi by 5, we have to verify. So substitute in the place of x pi by 5. P of pi by 5 is equals to 5 into pi by 5 minus pi is equals to 5 ones are 5 ones will get cancelled. Pi minus pi is equals to 0. So we can say here also x is equals to pi by 5 is 0 of given polynomial. What it is? P of x is equals to 5x minus pi. Next is seventh problem in third method. So 1 to 8 problems are given here to verify. So first, second and seventh one I will explain, remaining given to you as homework. So in third method, seventh problem, given polynomial is given as p of x is equals to 3x square minus 1, and this time x values are given to verify. Two values. One time we have to take x as minus 1 by root 3, and next time we have to take x as 2 by root. For what value of x? It will be 0. That is 0 of the polynomial. Coming to solution. First, if x is equals to minus 1 by root 3, then p of minus 1 by root 3 is equals to 3 into minus 1 by root 3 whole square minus 1, that is 3 into minus 1 by root 3 whole square means minus 1 by root 3 into minus 1 by root 3. Minus into minus plus 1 into 1 root 3 into root 3 whole square, that is equals to 1 by 3. Here square and root, square root and square will get cancelled, so it remains 3. So minus 1 by root 3 whole square means what we can write? 1 by 3 minus 1. So 3 ones are again it will get cancelled. 1 into 1 means 1 into 1 is 1 minus 1, which is equals to 0. And the next form 2 by root 3 also we'll check. X is equals to 2 by root 3, then p of 2 by root 3 is equals to 3 into x square means 2 by root 3 whole square minus 1 is equals to 3 into 2 by root 3 whole square means 2 by root 3 into 2 by root 3. So 2 2's are numerators. 2 2's are 4, root 3 into root 3 whole square, which is equals to 3. So 2 by root 3 whole square value is 4 by 3 minus 1. 3 ones are will get cancelled. 4 minus 1 is equals to 3, which is not equals to 0. So in the given values for x minus 1 by root 3 and 2 by root 3, which is 0 of the given polynomial, clearly for x is equals to minus 1 by root 3 only we are getting 0. One more thing you have to remember. Polynomials may have 1 zeros, 2 zeros, more than 2 zeros also. Linear polynomials always will have 1 zero. And next, quadratic polynomials may have 2 zeros. Cubic polynomials may have 3 zeros. So, we cannot say all polynomials should have only 1 zero of the polynomial. So different polynomials based on the type of polynomial, it may have 1 zero, 2 zeros and 3 zeros. So these things they have to remember. And the next fourth main. The fourth main is asking us to find the zero of the polynomial. So this time we have the not given to verify, asking directly to find the zero of the polynomial in each of the following cases. So answer. The first one is P of x is equals to x plus 5. Let equate this given polynomial to 0. Let P of x is equals to 0, which implies x plus P of x means x plus 5 is equals to 0, and x is equals to plus 5 transposed to right hand side, then it will become 0 minus 5 means minus 5. So x value what we got here, minus 5. So substitute here minus 5 in the place of x. So minus 5 plus 5 will be equals to 0. This is the process of finding when asked to find 0 of the polynomial. First we have to equate the given polynomial to 0. Then after that simplification. Then x value, the variable value we will get. So verify that variable, that what value we got, the given polynomial, again we will get 0. So then we can say it is the 0 of the polynomial. And the next sixth one. So 2, 3, 4, 5. All are same like the first problem how it is. So just substitute, just equate to 0 and simplify. You will get the 0 of the polynomial. Coming to sixth main, given as P of x is equals to ax, where a is not equals to 0. As usual, let's assume P of x as P of x is equals to 0. P of x means ax equals to 0. Ax means a into x. A is in multiply. A is multiplying x here. Transpose to right hand side. It will divide. Then x is equals to 0 by a. Therefore 0 by a means 0. A should not equals to 0. That's why given condition here. Otherwise 0 by 0 we cannot say. We cannot define. So what's the 0 of the given polynomial here? 0. So 0 only, the 0 of the given polynomial. And the next seventh one. Seventh one is given as P of x equals to cx plus d, where c is not equals to 0 and c and d are real numbers. Let assume P of x as 0. P of x means the given polynomial cx plus d, which is equals to 0. Now cx is equals to, so here plus d transposed to right hand side, it will becomes minus d. So 0 minus d which equals to cx is equals to minus d. Now c is multiplying with x transposed to right hand side, then x is equals to minus d by c. For what value of x it will be 0, for minus d by c. So minus d by c is said to be as 0 of cx plus d polynomial. So this is the process of finding when asked to find 0 of the polynomial. So this is today's class. Hope you understood. And in next class we'll meet with reminder theorem. Have a good day.